solve the system, give your answer as an ordered triplet. So we have three equations with three variables, and we want to find the values of all three variables where these three planes would intersect. So it's all of the values that would make each one of these equations all true. Okay, now knowing that, what we want to do is notice that we have three unknowns in each equation. And we really can't solve an equation until we have only one unknown. So we're going to need a way of getting rid of some of the extra unknowns. And once we do that in at least one of the equations, it's going to make it much easier to answer the rest. So when we dealt with two equations and two variables, that was a lot faster and simpler. This one takes a little bit more doing, and you have to be very careful and very organized. Otherwise, the smallest mistake will cost you all that work that you did. So you do need to be really, really careful as you're going through. So the first thing I recommend is to begin by eliminating one variable. So you'll pair up, say, these two equations and eliminate one of the variables. It doesn't matter which one, but sometimes depending on which one you decide to eliminate, it can make the whole process a lot smoother and faster. So you gain some experience as you go in determining which variables to eliminate. That's going to make your life easiest. If you want just something that's straightforward that you don't really have to think about, you can always choose to start by eliminating z and then eliminating y, solving for x, and then working your way back. I'm going to use my experience to notice that I think it's going to be easiest here to eliminate the y values because, or the y variables, because I see similar coefficients on all the y terms. So that'll make it easy for me to add a couple of equations together and get rid of y. So as you can see, the first equation and the second equation look like all I have to do is add them and the y is going to be eliminated. And it's good to number your equations so you can kind of keep track of what you're doing. So what I'm going to start with first is I'm going to add equation 1 and equation 2 to eliminate the y variable. And so let's start by bringing down the first equation, negative 5x minus 2y plus 4z equals negative 7. And the second equation, negative 10x plus 2y minus 3z equals negative 36. I'm going to add those together. So I'm just going to add them. So I combine like terms. My negative 5x and negative 10x gives me negative 15x. Negative 2y plus positive 2y is going to give me 0y, right? But we don't need to write that out. It's just 0 times y is just 0 anyway, and we don't need to write zeros. So now the y term's been completely eliminated. Then when I add the positive 4z and the negative 3z, I get 1z left over, okay? And then negative 7 and negative 36 will give me negative 43. Okay, so now I've made a fourth equation. Okay, now in that fourth equation, I have only x and only z. So now I'm going to go and use another combination of two of the original equations and eliminate y again so that I can use it and make a fifth equation to be used with the fourth equation. All right, so I'm going to use, let's see, how about the first equation and the third equation together? So I'm going to take equation 1 and copy it down again. Okay, negative 5x minus 2y plus 4z equals negative 7. Then I'll copy down the third equation, 20x plus 2y plus 5z equals 70. And now let's add those together and combine like terms. So negative 5x and positive 20x gives me positive 15x. Again, you see the y's will cancel out because I have negative 2y plus positive 2y. And then 4z plus 5z is 9z. And then negative 7 plus 70 is going to leave positive 63. So now I have a fifth equation, and that fifth equation has only the two variables x and z, just like the fourth equation has only the variables x and z, so that's convenient. Now I just have to eliminate another variable. Well, I'm noticing that the negative 15x in the fourth equation and the positive 15x in the fifth equation are going to cancel each other out. So that's what I'm going to do. I'm going to add the fourth and the fifth equation to cancel out the x term. So the fourth equation is negative 15x plus z equals negative 43. And the fifth equation is positive 15x plus 9z equals 63. And when I add those together, the 15x and the negative 15x cancel to 0x, so that's gone. Then positive z plus 9z is 10z, and negative 43 plus 63 gives me positive 20. Now I have a sixth equation with only z in it, and since there's only one unknown, I can easily solve for z here by dividing both sides by 10. So if I divide both sides by 10, I get z equals 2. So now in my triplet, I have one of the three variables solved. And now I can start working my way back. So now I can take the fact that z equals 2 and substitute it into my fourth equation. So let's do that now. I'll use, I don't know, red this time. All right, so I'm going to take my fourth equation and substitute z equals 2 and then solve for the remaining variable x. Okay, so I'm going to take negative 15x plus z equals negative 43. Then I'm going to take the fact that I know now that z equals 2, so I'm going to replace the z with the number 2, and now I can solve for x. So I'm going to subtract 2 from each side. If I subtract 2 from both sides, then I get negative 15x equals negative 45. And then if I divide both sides by negative 15, I get x equals negative 45 divided by negative 15, which is positive 3. So now I have another variable solved in my ordered triplet here. So I have just one variable left to solve, and that is the variable y. So I can use any one of my original equations and plug in the x equals 3 and the z equals 2, and then solve for the variable y. So does it matter which one? Not a whole lot, but I'm going to use equation 1 because it just has smaller coefficients and looks like it might be easier to work with. So I'm going to go ahead and do that now with the color, I don't know, we'll go back to green here. So now I have, we're going to take equation 1 and we're going to sub x equals 3 and z equals 2 and then solve for y. Okay, so my first equation, which is negative 5x minus 2y plus 4z equals negative 7. Kind of had to squeeze a little bit there. All right, so negative 5 times x. What is x? X is equal to 3. So I'm going to replace that. I don't know what y is yet, so I'll leave that as y. Then 4 times 2 equals negative 7. Okay, now I'm going to simplify and solve for z. So negative 5 times 3 is negative 15. Positive 4 times positive 2 is positive 8. Now I'll combine the negative 15 and the positive 8 to give me negative 7. And then after I do that, I just need to, oops, I keep rewriting a mistake here for some reason. Okay, so I have negative 7 minus 2y equals negative 7. Okay, so now notice I have a negative 7 on both sides, so those cancel each other out. And then I have negative 2y equals 0. And dividing both sides by negative 2, I get y equals 0. So now that is the last piece to finish my ordered triplet. Now it's a good idea to go through each one of your equations and plug in these numbers and make sure that each time you do that, it makes it the equation true, because all three equations have to be true. So that's really how you would make sure you got it right.